Hello friends, welcome in a lecture of fluid mechanics subject. Myself Mitesh Patel. I am an assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a model analysis. In this lecture, we discuss about the importance of model analysis, types of similarities between the model and prototypes, and the forces are importance for the model analysis. So let's start the lecture. First, we see the what is the model analysis and what is the need of model analysis. To identify or know the performance of hydraulic structure or hydraulic machine before actually construct or manufacture them. Okay, then first models are made and tested to get the required information, and this process is called the model analysis. In short, we can say that we first create the small scale model and tested them whether the performance is good, then and then we create the hydraulic structure or hydraulic machines. Okay, then this all over the process is called the model analysis. Now, what is the model? We know that the small scale replica of the actual structure is called the model, and prototype is a actual structure or actual machines is called the prototype in a model analysis. Model is not always smaller to the prototype, but in some case model may be larger than the original structures or prototype. Okay. Now, following three similarities must be ensured between the model and prototype for a model analysis. First one is a geometric similarities, second is a kinematic similarities, and third one is the dynamic similarities. Okay. Now we discuss more about the all threes. So first one is the geometric similarities. Geometric similarity to exist between the model and prototype, the ratio of the corresponding length in model and prototype must be same, and the included angle between two corresponding sides must be same, and the model which are not geometrically similar are known as a geometrically distorted models. So for a geometrical similarity, in short we can say that if the length of model and prototype ratio is a constant, then it's called the geometric similarity. The model is geometric similar to the prototype. Okay. So in mathematically, we describe the geometrical similarity. You see that Lm is the length of model, Hm is called the height of model, Dm diameter of model, Am is the area of model, and Vm is the volume of model. And Lp, Pp, Hp, Dp and Ap and Vp is the corresponding value of prototype at a corresponding point. Now, for the geometrical similarity, we must have the relations Lm upon Lp, means the length of model upon length of prototype. The ratio of length of model to length of prototype is equal to ratio of model to prototype of width, ratio of height model to prototype, and ratio of diameter model to prototype are constant. The all ratios must be constant. So if model is said to be in geometrical similarity if fulfill these conditions, means the all ratios are cancels of the constant of the dimensions. All the dimensions ratios must be constant. Then and then the model is called the geometric similar. In case of ratio of area is a LR square. Okay. Now LR is called as a scalar ratio or scale ratio. Okay. So for a ratio of area of model to area of prototype is equal to LR square. Okay. And for volume ratio is a volume of model to volume of prototype is equal to LR cube. Okay. So we know that mathematically if model fulfill this condition, then and then call the model is geometric similar to the prototype. Okay. Now see the kinematic similarities. Kinematic similarity is a similarity of motion. If the corresponding point in the model and in prototype the velocity and acceleration ratio are same and velocity or acceleration vector point in the same direction, the two flows are said to be kinematically similarity. So in kinematic similarities, the flows in model and prototype, the velocity of and acceleration of flows in model and prototype or its ratio is a constant. Okay. Then the flow is called the kinematic similar. Okay. So we see in mathematical V1 m means the velocity of fluid at a point in model. V2 m velocity of fluid at a point 2 in model. A1 m acceleration of fluid at a point in model. A2 m acceleration of fluid at point 2 in model. Similarly, V1p, V2p, A1p, A2p is equal to corresponding value at the corresponding point of fluid velocity and acceleration in prototype. This value for model and these all values for prototype. Okay. Now for the kinematic similarity, we must have ratios of velocities at a point 1 for model to prototype and velocities ratio of velocities at a point 2 for model to prototype is a constant, or we can say that VR is the velocity ratio. It must be constant. Okay. Or both having a same value. Similarly, for acceleration at a point 1, that means the ratio of acceleration at a point 1 for model to prototype, or ratio of acceleration at a point 2 for model to prototype, it's same or constant. Okay. Then and then this two flow in model and prototype is called the kinematic similar. So for a kinematic similarity, we must follow the flow these conditions. Okay. The ratio of velocity at model and prototype at any point must be constant. Then and then model is kinematic similar. And the two notes are there. The direction of velocities in model and prototype is also must to same. Okay. And geometric similarity is prerequisite for kinematic similarities. In short, we can say that if model is geometric similar to the prototype, then and then we get the kinematic similarity. So for a kinematic similarity, model must be geometric similar to the prototype. Okay. Now dynamic similarities. Dynamic similarities is the similarity of forces. The flow in model and in prototype are dynamically similar if at all corresponding points, identical types of forces are parallel and sham ratio. Okay? In short, we can say that at any point, at any corresponding point, the ratio of forces in model and prototype is a constant. Then the model is called the dynamic similar to the prototype. Okay? So mathematically we saw the Fim means the inertia force at a point, at a corresponding point for model. Okay? Fv is a viscous force at a point in model. Okay? Fg is a gravitational force at a corresponding point in model. Similar way, Fi, Fv and Fg for a prototype. Inertia force, viscous force and gravitational force for a prototype at a corresponding point. Okay. Now, for dynamic similarities, we discuss that the ratio of forces means inertia forces for a model and prototype is equal to ratio of viscous forces for model to prototype and ratio of gravity forces at for a model and prototype at a corresponding point is must be same, or we can say that the constant. Then and then the model is called the dynamic similarities. Okay, or similar. Okay, so must fulfill this condition for the dynamic similarities. Okay, then and then model is called the dynamic similar. And the direction of corresponding force at a corresponding point in model and prototype is also should be the same. Direction and forces, ratio of forces is constant and direction is must be same. Then the model is dynamic similar. So also direction is also considered for the similarity and for a kinematic and dynamic for both. Okay. So I hope that you very well understand the similarities, all three types. Now we discuss about the forces which are important for the hydrodynamic phenomena or model analysis. Okay. So first one is the inertia force. We know that the inertia force is always exists in a fluid flow problem, and it is the equal to the product of mass and acceleration of flowing fluid. And inertia force, we know that always act in the opposite direction of acceleration. Okay, this is the inertia force. Okay, now second one is the viscous force. It is always present in a fluid flow problem, and it is a play a very important role in the fluid problems. What is the viscous force? How we get? It is the equal to the product of shear stress due to the viscosity and surface area of flow. Product of shear stress and surface area. Okay. Now third one is the gravity force. It is present in case of open surface flow or open channel flow. It is equal to the product of mass and acceleration due to the gravity. We know that the gravity force is find out through the mass into gravitational acceleration product. Okay. Now next one is the pressure force. This type of force is a pressure present in a case of pipe flow or compressible flow or turbulent flow. It is equal to the product of pressure intensity and cross section area of flowing fluid. We know that the find the forces for pressure, so we can know that the pressure force is equal to pressure into cross section area. Now next is a surface tension force. It's also important forces for a fluid mechanics problem or model analysis problem. It is equal to the product of surface tension and length of surface of flowing fluid. Okay. It's a very important force for a fluid mechanics. Elastic force is also important force. It is equal to the product of elastic stress and area of flowing fluid. Okay. I hope you very well understand all things, similarities, importance of model analysis, and all these forces. Okay. Thank you. If you have any query related to this topic, then feel to ask to me. Okay. Thank you again.